We want to simplify this expression. That means to make it as compact and efficient as possible. And we're going to do that by factoring and then canceling any common factors. So let's factor the top. We'll factor the bottom. So doing so will give us, now we can take a 5 out of the top, and if we do that, we're left with y minus 3. And we can take a 7 out of the denominator. That'll leave us with a y minus 3. And what do you know? These y minus 3's will cancel, and then we're going to be left with 5 over 7. Now, when we say that these cancel, we mean they divide out, right? Y minus 3 divided by y minus 3 is 1. Then you get 5 over 7 times 1. But for short, we just say that they cancel. And I'm going to say it like this, is that this is inefficient, right? We start here with 5 over 7. We multiply it by y minus 3. Then we divide it by y minus 3. That's inefficient. So we're going to cancel that inefficiency. And we're going to claim then that the original expression can be written more efficiently as this new one. So let's do that. So we're going to claim that the original is this as long as y is not equal to, now follow it back up here. What can y not equal? Y can't be 3, right? Because that's going to give us a 0 here and a 0 here, and we don't divide 0 into 0. So as long as y is not 0, we can replace this expression with this one. Let's factor this. Difference of 2 squares up there, oh, that makes a big mess. Difference of 2 squares up here. So let's factor. We will get y plus 4, y minus 4, right, those conjugates, all over that y plus 4. And now we can see that this y plus 4 here will cancel with this one, and we're going to be left with 1 times y minus 4, which is y minus 4. And we can do this as long as, right, what's going to make that 0? Negative 4. So once you get to this part right here, all you have to do is look back up to the next step and see what you canceled. And anything that's going to give you 0 here, you have to write as, this is true as long as y not equal to 4, right? Because if y is equal to 4, this is a 0, this is a 0, and then you're multiplying by 0 over 0, which we don't do. Number 10, let's factor. We can take a 4 out of here, and in the bottom we have difference of 2 squares. So we are going to take that 4 out, we'll be left with x minus 3, and in the denominator, we'll get these conjugates, right? X and x, 3 and 3, make 1 plus, 1 minus, and now we can see this x minus 3 is common to both the top and the bottom, so we're going to cancel that, and then we're going to be left here with 4 over x plus 3, and we're saying then that this original expression can be replaced with this new, more compact, more efficient expression, and we can do it as long as, okay, look back up here, what's going to make that denominator 0? Well, negative 3 from here, positive 3 from here. So we're going to say x not equal to negative 3 and positive 3. Let's factor this top. So, and then look to see if there's an x minus 4 down there, in which case it would cancel. But let's factor this, see where it takes us. So we're going to get, how about x and x? Now, what are these factors of 20 that we want to use? 20 and 1 is not going to work. I can't get a 1 out of that. 10 and 2? No. How about 5 and 4? I can get a 1 out of that one. So let's go with a 5 and a 4, and it's minus 20 here, right? So these two numbers have to have opposite signs. I'm going to put that middle plus sign with the bigger product. And the way I've written mine, the inner product is 5x, which is bigger than the outer product, which is 4x. So I'm going to put that middle plus sign here with the 5. So how about x plus 5, x minus 4, all over x minus 4. And I can see the x minus 4's are common, so let's cancel those. And we're going to be left here then with x plus 5. So what we're saying now is that this original expression can be replaced with this much more compact, more efficient expression, as long as, now just follow it up here, as long as x is not equal to 4, right? X not equal to 4. what we're saying is that instead of computing with this expression, right, given a number, put it in for x, you could just put it down here. Much more quick, much more efficient. In 12, we need to factor the top and factor the bottom, so let's do that. So we are going to get in the top about x, and I'm thinking 7 and a 2. I'll make it a negative 7 and a minus 2. That'll give us a negative 9 and the positive 14. And then over, let's see what we get here. Now, as we do this, aren't you expecting, when you factor this, aren't you expecting one of these to match one of these? Let's see if it works. So let's see, what do we want to use here? So we'll use an x and an x. Now for the 18 and 1 is not going to work. 6 and 3, I can't get a 7 out of that, but a 9 and a 2 will work, and sure enough, I'm thinking these are going to match. Now this 18 is negative, so these numbers have to have opposite signs. I'm going to put that middle plus sign with the bigger product, 9x bigger than 2x. So let's put the plus right here. That'll give us plus 9 minus 2. And then sure enough, these x minus 2's we can cancel. And we're going to be left with then x minus 7 over x plus 9. And then what we're saying is that this original expression, this set of computing instructions, can be replaced with this much more compact, more efficient set of instructions as long as x is not equal to, now just follow this right back up here. What's going to make that denominator 0, right? Don't worry about the tops, just the bottoms. We don't want those to be 0. What's going to make it 0? Negative 9, positive 2. So negative 9, positive 2.